You're listening to the N2K Space Network.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, session hijacking, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, session cookies, and PII siphoned from malware-infected devices. With knowledge of the specific exposed data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation that fits seamlessly into existing incident response frameworks. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show.
Space jumps back in the atmosphere with drops of lithium in its trail. It looks like metal and it falls like rain. Reminds me there's so much at stake. Since the satellites began to fly, it looked like rocket, but it ruined the sky.
T-minus 20 seconds to LOS egress. Go for deploy. Roger roll.
Today is October 19th, 2023. I'm Maria Varmazis, and this is T-minus. Space junk is polluting Earth's upper atmosphere. Australian and Chinese satellites experience a near collision. Commercial space companies ask for less red tape. And we're continuing our preview of speakers from next week's Ascend conference. And today I'll be chatting to Emma Loudon, an astrophysicist from Yale, about her participation in the AIAA event. On to today's intelligence briefing. At the top of the show, you were serenaded by the dulcet tones of our T-minus executive producer and balladeer, Brandon Karpf. And if you're going to be at Ascend next week and feeling brave, challenge him to a karaoke contest. I double dog dare ya. Not that I'm going to cast any aspersions at Brandon for bursting out into song, but there was a good reason for it in our show today. He was inspired by the muse of peer review, as there's a new study in the Proceedings of the National Academy of Sciences that shows evidence that, as long suspected, all that space junk we've been burning up on reentry to Earth is indeed leaving behind detectable levels of heavy metals in our atmosphere. 11 miles above the Earth's surface, NASA's WB-57 and ER-2 research aircraft found traces of lithium, aluminum, copper, and lead in the thin air of the stratosphere, which is way higher than any Earth-based air pollution source could possibly reach. The ratios of heavy metals they detected actually rather neatly mirror the ratios in satellite alloys, and they are in greater concentration than anything that a meteorite could leave behind. The new study says that 10% of the Earth's large sulfuric acid particles, which protect the ozone layer, contain these heavy metals, specifically originating from rocket stages and satellites re-entering the atmosphere. And if we keep on the path we're going for satellite numbers, as well as current disposal practices, the study projects that half the protective stratospheric sulfuric acid particles would have metals in them. And we have absolutely no idea what kind of effect that would have for the protective ozone layers, and of course for all of us here on Earth. I am Trying not to freak out, but I am freaking out a little bit. So, okay, let's try to focus on something a little more positive for the next story. This one comes from ABC News Australia of a near miss earlier this month between an Australian and Chinese satellite. It's a great case study in collaboration between the private sector and military space. The near miss in question was flagged by Australia's Defence Space Command, which quickly worked to warn Skycraft, the Canberra-based company whose satellite was at risk, that its spacecraft was going to come real close to another satellite. And we're not even talking a matter of kilometers. Try just a few hundred meters close. And that would have happened if something wasn't done to avoid a collision. Here's Air Vice Marshal Kath Roberts' recall of what was going on.
Some initial analysis showed that one of his satellites might be in a conjunction situation, and we thought that it was originally within, I think it was 9 kilometres. That, of course, concerned me, probably concerned you as well, because we were worried about the potential for creating debris.
Skycraft went to work activating their response plan, and crucially, they had information coming from both Defense Space Command and the United States Air Force to help them figure out what to do next. And while the Australian Defense Department isn't commenting or attributing an identity to the other satellite in this near miss, some sleuth work by ABC News Australia revealed that the satellite was a Yaogan 37 belonging to China. 16 hours before the near miss or conjunction event, the Yaogan 37 maneuvered to increase its distance to 978 meters from the Skycraft satellite. And had it not done that, the two satellites would have gotten within about 100 meters of each other. Was this near miss an accident because low Earth orbit is just getting so dang crowded? Maybe. Was this near miss on purpose for the purposes of subterfuge? Also maybe. We have no way to know either way, of course, but between the proliferation of satellites in LEO and the increase in the number of near misses like this one, the risk of unintentional creation of space debris is higher than ever. Oh, fantastic. The U.S. Subcommittee on Space and Science convened a hearing yesterday titled Promoting Safety, Innovation, and Competitiveness in the U.S. Commercial Human Space Activities. The hearing focused on human activities in the growing commercial space sector, covering safety, global competitiveness, and the federal government's role in regulating human activities in space. Experts testified about the importance of streamlined authorization processes, safety regulations for in-space operations, and responsibilities of government agencies overseeing commercial human space activities. William Gerstenmaier, the Vice President of Build and Flight Reliability at SpaceX, said this of the Federal Aviation Authority's Office of Commercial Space Transportation, also known as AST.
With that said, I want to focus my testimony on AST's regulatory framework for launch and reentry licensing, which is in great distress. I want to state clearly that AST is an outstanding and important organization that needs more resources and immediate regulatory direction from Congress. AST's role is critical to enabling safe space transportation, but we're at a breaking point. AST has neither the resources nor the flexibility to implement its regulatory obligations. Licensing, including environmental approval, often takes longer than rocket development. This should never happen, and it's only getting worse. Our Starship, Falcon, and Dragon programs are encountering regulatory headwinds and unnecessary bureaucracy that has nothing to do with public safety. Regulation is important, but so are the technical challenges associated with developing and operating transformative vehicle systems like Starship.
Now, given the recent FAA assessment on reentry disposal of satellites, you'd think that more oversight would be welcomed so we're not assessing space threats retrospectively. But hey, SpaceX, what do we know about the possible 28,000 pieces of space junk that we can expect in 2035? Moving on. And U.S. space startup Cognitive Space is on a roll. Last month, the company was named in the top 10 satellite solution companies of the year. Earlier this week, they announced $4 million in a seed plus funding round, bringing the total capital they've raised to over $10 million to date. And they have been selected by the Space Development Agency for 2 contracts with a combined value of $3.22 million. Cognitive Space is developing an AI-powered software as a service, aka SaaS, designed to enable satellite constellations to grow and scale. The SDA contracts will utilize the company's cognitive inference tasking software platform for their transport layer. And the Space Development Agency is looking for industry feedback on potential space antenna array payloads, which could prove valuable for future tranches and/or experimentation. The SDA says antenna arrays provide benefits from beam agility to interference rejection, but have typically been associated with high cost, power, and size. However, recent advances have reduced the barriers to employing these antennas on SDA satellites. Responses to this request for information will inform SDA on the technical and manufacturing readiness of the antennas required for future efforts, such as Tranche 2 demonstration and evaluation system, Tranche 3 transport and tracking layers, and other SDA efforts. Responses to the request for information are due by November 17th, and the link to the full RFI can be found in our show notes. Starwind announced that it has successfully tested its electronically steered phase array antenna terminal for communications on the move on Avanti Communications high-speed HILAS 4 Ka-band satellite. Starwind says this achievement is a significant milestone for mobile satellite communications that will provide seamless broadband connectivity for government, military, and enterprise customers across Africa. And Virgin Galactic have released the date of their 6th and final launch of the year. They will be launching 3 passengers, including planetary scientist Alan Stern, to space on November 2nd. And we spoke to Alan about his upcoming launch in episode 124 of this show.
I was selected in 2020 by NASA to fly an astronomy experiment and a space physiology experiment on a Virgin Galactic mission. That's going to be in the future, after Virgin's flown enough flights that NASA can clear that. They want to get a longer track record. But in the nearer future, I'm going to be flying a training flight to get some practice so that when I flight for NASA, I'm not going to be a rookie. And I'm really looking forward to both of those flights to space, expecting that the NASA flight's going to tell us a lot about how good Virgin Galactic spaceship is for doing astronomy.
We've added a link to that full chat in our show notes, along with links to further reading on all the stories that we've mentioned today. We've also included an Axios piece on AI giving the growing space industry a boost. All these pieces and more can be found in the selected reading section and at space.n2k.com. Hey T- crew, if your business is looking to grow your voice in the industry, expand the reach of your thought leadership, or recruit talent, T- can help. We'd like to hear from you. Just send us an email at space@n2k.com or send us a note through our website so we can connect about building a program to meet your goals.
This episode is brought to you by Palo Alto Networks, the leader in cybersecurity. As AI-driven attacks increase, organizations can't afford to have network security that's stuck in the past. Discover how Palo Alto Networks can help you predict what's coming and proactively secure against it with a zero-trust, AI-powered network security platform built to secure whatever, whenever, wherever. To learn more, visit paloaltonetworks.com/network security platform.
We're just a few days away from the start of the 2023 Ascend Conference in Las Vegas. T- will be there, and all week this week, we're featuring speakers from the event. Today, I spoke to Emma Loudon, an astrophysicist from Yale, about her participation at Ascend.
I'm really excited to be returning to Ascend for I guess this will be the third year in a row. It has rapidly become my favorite space conference to attend. I am really excited to be coming back this year with the first ever iteration of what we're calling the Astro Debates, which is something that Rob Meyerson, Karen Shenwick, and I put together with the goal of really having kind of thought-provoking and professional development kind of conversations, but in the context of a debate. So we're really excited to be bringing this to Ascend this year. We're going to have teams of participants who are going to be mixtures of industry professionals and young professionals who are going to be debating on a list of topics, which you'll get to hear more about on the first day of the conference.
Oh, you can't spoil the little preview. Little preview.
No, but I can tell you that you'll get to have some input in which ones the people will be talking about on Tuesday at the session.
Okay. All right.
So that'll be really fun to have the audience input. And then it's going to be kind of panel of experts on each of the topics to be able to respond to what's being talked about on stage and kind of synthesize in real time and answer audience questions. So I'm super pumped about that. And then I'm also going to be on a panel on Wednesday morning, organized by the amazing Shauna Pandya, who's going to be talking about why are we even interested in space right now? Like why, but why space? So I'm all topics that I am super, super excited about and passionate about. So I'm really looking forward to Ascend this year.
In 2021, you were part of the Diverse Dozen, and you gave a really fascinating presentation on stage. Could you tell the audience a bit about that if they haven't seen it?
So I was really honored to be chosen as one of the Diverse Dozen that year. They choose 12 every year, as the name suggests, of people from all over the world who are interested in space sustainability and thinking about space traffic management from different perspectives. And I came into that conversation really emphasizing less of my background in like technical work and more of my background actually as a debater in high school, where I learned a lot about how to communicate. So I, since then, I'm always fascinated by like rhetorical analysis and how do we talk about things that are important and how does that impact how people think about them. When it comes to satellites and the increasing number that are orbiting our planet and how do we fix that problem, when I sat back to think about, okay, what do I want to say on this stage? It really came down to not like, what is a technical solution for this? What are the like building blocks of things that we're going to need to solve it that way? Even what are the legal frameworks that we're going to need? Because there are people who devote their entire lives to that, and that's really important. But what I was thinking about was, how do we even get all the right people in the room to have these conversations? Like, how do we make people care? To me, that comes down to the story that we're telling about space and the story we're telling about space sustainability. And so being able to define a story that we can tell that brings the right people into the room and convinces them that this is an important topic is important in the context of space sustainability, but also important more broadly. I think it's part of this kind of shift that we're seeing in the space industry and also outside of it, where we're redefining as a society, what does it mean when you think about space exploration? Because it used to be that the first thing people thought of was Apollo and they thought of NASA. Now I'm not so sure that those are the things that people think of. And I think it's really important to be redefining how, like, what is the story of space that we're telling? Because those messages that used to really convince people in the past, they don't work now, nor should they. I mean, we have a world that is vastly different than it was 70 years ago. But we know, I mean, people who are in the industry know that space has this tremendous value to the world right now. But it's a matter of conveying that value in a way that brings people to the table so that they can share their ideas and we can all be better for it. So that was kind of what that focused on. And it was a really fun presentation to give. And it's something that I've continued to be really passionate about and will continue forever probably, is that telling the story of space in a way that pulls everybody in.
Yeah. I mean, a lot has changed in the space industry and just the use of space in those intervening years. I'm curious, like, what your thoughts are on what has happened since then and, like, where are we? Has that story changed or, like, has our approach to that story changed? Your thoughts on that?
I mean, I think the story that's being told in generally has definitely changed. We've seen the huge increase in number of private space flights, and that's really shifted a lot of public perception of what space is. But I think at the same time, we've also seen this huge increase in the number of satellites, which while there's concern for that, obviously, like we care a lot about space traffic management, we care about what that's going to do to telescope data. There are a lot of reasons to like be a little wary of all of it. The huge increase in number of satellites is also bringing out data in the likes of which we have never seen before. I mean, the fact that you can go to a space conference and have people talking about their work with like John Deere, like the tractor company, like the fact that a company like that is buying space data to me is emblematic of how space data is really permeating all of our lives. We're still not very good as an industry at telling that story yet and helping people see how like every day they touch something that is connected to space in some way, shape, or form. And also that a lot of the issues we care most about, either they're being reported on using data from space or they're in like those solutions can be informed by space. So like climate change, for example, we can get such good data about where the animals are migrating, for example. And we can do that with satellite data. Like there's really cool stories of like trying to figure out where cities should expand or not expand based on tracked migration wildlife patterns from satellites. Or even in when there are big world events that like earthquakes, things like that, that are reported on in newspapers, a lot of the imagery, if you go and trace the resources, it's all satellite data. I don't know. I think that the story is changing because the volume of what we have around us is changing, but there's still room to really bring out that sense of empathy and connection amongst everyone to fold them into that story. We still have a long ways to go.
Yeah, I use the word existential a lot, and maybe I shouldn't do that, but to me, it does feel like if we can't bridge that conversation a little bit better, we're going to have a problem as an industry in general. So, I mean, those of us, again, who are in it, we get it. And then there's a lot of people who are just like, why are we thinking about this? And we all confront it every day.
Well, we're already seeing that, I think, in that the industry has so many open jobs right now. And there are companies that are competing with each other to try and hire young people to these jobs. But then there are a lot of young people who are saying, why would I work in space? Like, when I want to fight climate change, when I want to be part of humanitarian aid, when I want to be part of any one of a number of things, and don't see themselves in the space industry. It ties back to this whole problem of if you can't picture yourself in a role, then the chance of going and pursuing it is much lower. So being able to connect those dots as we tell this story and say, you want to work in climate change, go work for this company that is helping to collect data on a daily basis that informs like where people are going to need to move in like early disaster prevention. Or if you have people who know how to use and interpret satellite data in maybe the State Department so that they can inform policy based on that. Like there's so many cool opportunities that are missed right now because of this story not being as widespread or as inclusive as it needs to be, frankly, for the 21st century.
You talk about the intersection of astrophysics as an astrophysicist yourself and the aerospace industry. So can you talk to me a little bit about that? Because that is something I've had a few guests on the show who've talked about that who are astronomers, astrophysicists, and they've talked a little bit about like how satellites affect their work. And that's kind of been the most that we've talked about it. But I'd love for you to talk a little bit more about it if you could.
Yeah. So I actually came upon that kind of distinction very early on when I was first dipping my toes into the space industry. In 2018, I had the absolute privilege of being a Brooke Owens Fellow, and I got the chance to spend my summer in Washington, D.C. And while I was there, I was working for Bryce Tech, and as a part of that, I got to go to Capitol Hill and go to hearings, and I got to do work that really showed me this vast landscape of the space industry that I didn't really have an understanding of before. I was so excited. And I went back that fall to my department for undergrad at the astrophysics department. And I was talking about all these companies and all these things that were happening in space policy and just generally in the industry. And broadly speaking, I was met with, oh, I didn't know that was happening. Or, oh, what is that company? Or, oh, like, what is that even like something people are talking about? And as I continued on, that's been like the critical insight in my journey is that the astrophysics world and the space industry world, while both doing things that look up at the night sky that are for space exploration, they don't really talk all that much except for like very specific hubs.
That blows my mind a little bit.
Right? It blows my
Yeah.
mind every time I say it. So I think about it mostly from the context of what are the people who are then missing out on these connections. So the side of from satellites is really important to be talking about too. But from a people side, there are not enough jobs in academia for everybody who gets a PhD in astrophysics to go into academia, nor does everybody want to go into academia. But so then the pathways then are usually into either data science or finance or teaching at like a K-12 kind of level, all of which are very important jobs. But also a lot of them then carry this shift in mindset where people have to go from working about something that is really passion driven. Like you don't study astrophysics because you're like, I don't know, you don't like just stumble into it usually. Like you really love the night sky and you love space. And so to not have a clear pathway for people to go from astrophysics into the space industry, to me seems like you're missing out on a bunch of passionate and talented people who could be easily adaptable to various jobs in the industry. Because PhDs, well, as companies right now aren't necessarily doing astrophysics, they do need people who know how to handle large volumes of data. They need people who know how to think on their feet. They need people who are good at project management, all of which are skills that you're learning as a PhD student. That's where a lot of my interest right now is in trying to help people see, oh, maybe I should go look for jobs here, or like go into this industry, go attend some of these conferences, just kind of like explore it a little bit and see if it strikes your fancy, because it'll work for some people it won't, but like it's a good way to maintain that passion and to build out a passionate workforce within the space industry.
We'll be right back.
Now, a word from our sponsor, the Johns Hopkins University Information Security Institute, currently seeking qualified applicants for its innovative Master of Science in Security Informatics degree program. Study alongside world-class interdisciplinary experts and gain unparalleled educational, research, and professional experience in information security and assurance. Interested U.S. citizens should consider the National Science Foundation's CyberCore Scholarship for Service program, which covers tuition and a $6,000 annual professional development allowance, as well as providing a $37,000 additional annual stipend. Apply for the scholarship and the fall semester by March 1st. Learn more at cs.jhu.edu/MSSI.
Welcome back. And I've got a nerdy one for you today. From Excalibur to Gurtang in Tolkien's Silmarillion to Sokka's space sword in Avatar: The Last Airbender, I can easily think off the top of my head of examples from folktale and fantasy of when meteoric iron makes an appearance to forge a unique and powerful sword. Special rocks from space to make a fantastic sword is such an old trope that it seems timeless. But just how far back does it go exactly? Well, a little history lesson first. The start of the broadly defined historical metal age known as the Iron Age, when many cultures around the world, from China and South Asia through to Egypt, Anatolia, and later Europe, figured out how to smelt and smith iron for tools and weapons. Really depends on what culture you're looking at, but many historians roughly start the Iron Age between 1300 and 900 BC. But iron was used by cultures around the world well before that. And of interest to us right now is meteoric iron, as in iron that comes special delivery to Earth by meteor. And it has been found in use from cultures all over the world. In fact, the oldest identified iron object is 5,300 years old, found in Egypt, actually. Still, I should note that unlike the hero swords in many a fantasy tale, meteoric iron historically was, and still is, extremely rare and fragile, so its use was relegated to ceremonial or ornamental use, famously in the meteoric iron dagger that was found in King Tutankhamun's tomb. But how timeless is the nature of meteoric iron? In other words, how long ago did people realize that meteoric iron actually had off-planet origins? Well, this fascinating question was posed in a recent Smithsonian Magazine article which quotes some new research from Egyptologist Victoria Almanza Villatoro. In studying hieroglyphic texts from a 4,400-year-old pyramid, Almanza Villatoro found this text: "The King Eunice seizes the sky and splits its iron." And the word for iron in both ancient Egyptian and also Sumerian, which was spoken 5,000 years ago in Mesopotamia, also contains the word or sign for sky. Almanza Villatoro believes that the two cultures came to the same discovery of meteoric iron's heavenly origin on their own, independently. And for the ancient Egyptians anyway, they explained the connection in a ritual pyramid text, saying that the sky was an iron bowl made of water, with pieces falling to earth either as rain or as meteorites. The ancient Egyptians didn't know about the stellar origins of meteoric iron necessarily, but in their own way, they figured it out. To them, meteoric iron and the sky were inextricably linked. That's it for T- for October 19th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T- are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer and balladeer is Brandon Karpf. Our Chief Intelligence Officer is Eric Tillman. And I'm Maria Varmazis. Thanks for listening. We'll see you tomorrow.